What am I supposed to do? Okay, on your notes, you should see this. A transversal is a line that intersects two or more coplanar lines at distinct points. So when you see that definition, what I want you to realize is that if you have two lines that gets intersected by another line, then this is a transversal. We're going to call it transversal T. And our lines are L and M. Notice that the green line that I have here intersects both L and M. L only intersects one line, right? L only intersects line T. M only intersects line T. So you know that the transversal has to be the green one. Does that make sense?
Yes.
Well, if we put the angles on here, we number them. 1, 2, 3, 4, 5, 6, 7, 8. We can fill in these phrases or sentences and talk about the angles. Which angles are between the two lines? Angle numbers.
4, 3, 5, 6.
Thank you. Angle 4, angle 3, angle 5, and angle 6. They're between the two lines. So those are my yellow angles. They are called interior angles. That's a vocab word. So interior angles are anything that are between the two lines that are intersected by the transversal. Which angles are outside of the two lines?
1, 2, 8, 7.
1, 2, 8, 7. Thank you. And based on what I just told you about interior angles, what do you think those angles are called? Exterior angles. So these angles are my blue angles. Those are exterior angles. Anybody have questions about interior or exterior? Good? Is this what you have next?
Yeah.
So the map at the right shows the intersection of Maple Street and Oak Street by Main Street. Now what I want you to do is I want you to take a moment and look at this diagram and imagine for yourselves that, let's see, we have Maple Street, which is this line, and then we have Oak Street, which is this line, and then we have one that hits both of them, Main Street. So, Main Street is going to be called what? Transversal. Thank you. Now, do you remember? Yes, you do. From vocabulary, we had certain angle pair relationships. Okay? Well, what we're looking here is we're relating that to a map. It's a real life situation. So we have the town hall, which is right here, and the gas station, which is right here. Can you see those X's?
Yeah.
What is the angle pair relationship between the gas station and the town hall? They're interior, and what type of interiors? Are they alternate? That's the same side interior. They're on the same side of what? Thank you, of the transversal. Okay, does that make sense? If you look at that blue line, the highlighter line, as a transversal, they're on the same side and they're between the two magenta lines. How about if we look at the school, which is over here, and the library, which is up here. School and library.
Corresponding.
Corresponding. Okay, what I like to get people to remember, because corresponding seems to be the one that students struggle with the most. But if you look at this, if I say that Oak Street is my line, and we know that the blue is a transversal, the school is above the line and to the left of the transversal. Does everybody see that? Okay, and then the library is above the line and to the left of the transversal. That's how we know that they're corresponding. If you're describing their position, it's exactly the same. Okay, so let's say I put it here. Where would you describe the store as?
Seems.
Okay.
Wait, interior.
No, I don't, I'm just saying, if you had to describe where the store is, what would you say that it's above or below the line? And what side of the transversal? Left. So you know that that's not the same description. Make sense? Okay, let's keep going. We're looking for the library and the post office. Library and the post office. Oops. There. So library and post office. What kind of exterior? Alternate exterior. You gotta have the whole name. Thank you. And the school, the school and the gas station. Alternate interior, thank you. Make sure you put an E on alternate. Anybody got questions about any of those? Memorizing. You're going to have to memorize. But the positions should make sense. If they're interior, if they're exterior, if they're alternating, which means you're jumping back and forth. All right? Let's keep going. Okay, let's do a little bit of review before we start playing with A's and O's. Someone please tell me the corresponding angle pairs using the numbers that are given to us. Corresponding angles. Yes. Wait 1 second. Go ahead, Brenda. Yes. Wait a second. 1 and... Okay, someone help her out. Andrea? Wait a second, I can't hear you. Yes, angle 1 and angle 5. You see that, Brenna? They're in the same position. Above the line and to the left of transversal is 1. Above the line and to the left is 5. Someone else. Angle 2 and...
We don't have
Please make sure you're writing that down. No, you need to write that down. That's not on your paper. On the right of that picture, you need to write that down, please. The name and then the angle.
Angle 3 and... Angle 7. And the last one is going to be angle 4 and angle 8. Thank you. Let's pause a minute and let you all get this down. Okay, so now, alternate interior. You with me, Waldell? No? 1 and what? Wait, I said alternate interior. Okay, give it to me. Mr. Danielson.
Let's get 3 and 6.
Thank you. You see how I had to think about it? All right, Kelvin, do you see how the angle 3 and angle 6 are alternate? They're on opposite sides of the transversal. And you see how they're interiors? So tell me the other one.
4, 5.
Thank you. Angle 4 and angle 5, because by the end of the year, you all are going to be speaking geometry language to us. Same side interior.
Angle 3 and
Angle what?
angle 4. 3,
Okay, wait a second. Same side of what, Precious?
4. The transversal.
Ah, Suki.
Angle 3 and angle 5.
Thank you. Somebody else? Yes, Brennan. Awesome. All right, now Kelvin should be happy because finally we're going to talk about alternate exteriors. Somebody give me an alternate exterior. Rob, 1 and, yes, thank you. Angle 1 and angle 8. And what's the last one? I'm sorry. Janet? Angle 2 and 7. Thank you. See, if I keep talking to you, I'm going to remember names. All right, now we've named all of these angle pairs. And the more you use them, the more you'll remember them. You need to memorize these names. But as you see, there's little tricks you can remember. Where are they? On the same side of what? Corresponding to what? Okay? Well, there is something, though, that we're introducing to you today, is that if the transversal intersects parallel lines, there's something special that happens. If you have a pair of parallel lines cut by a transversal, then the angle pair relationships have very unique angle measurement
Right
relationships.
angles.
Hmm?
Right angles.
Well, are they always going to be a right angle? No. But what you do get is every time a line intersects another line, you're going to get an obtuse angle, and that obtuse angle is going to be sitting next to an acute angle. But we also know that that acute angle is always going to be vertical to what? Wait, I said vertical. Acute. And that one's going to be a linear pair with an obtuse. Okay, so let's do the same thing. In the same corresponding position, this angle number 5 is going to be an obtuse angle. Corresponding angle 6 is going to be acute. Corresponding to 4 is going to be an obtuse. And corresponding to angle 3 is going to be an acute. This relationship will exist with every time you have parallel lines cut by a transversal. Now, the only thing that will change the way that the pattern is if we give you a parallel line and the transversal is going this way. Let's talk about it. What kind of angle is this, an obtuse or an acute?
Obtuse.
Don't leave a sister hanging. Okay. What you notice is the linear pair is always going to be one obtuse and one acute. What's kind of nice is that wherever you put your A's and O's, from one line of the parallel pair to the other, you're always going to have your obtuse angles measure is going to be equal to the other obtuse. The acute angle is going to be equal to the acute angle. And then what do I know in this linear pair about an obtuse angle plus an acute angle? Oh, Suki. They're always supplementary. So whenever we put angle measures on here, you can figure out all the angles for both parallel lines. Awesome, yeah? Just have to remember that wherever there's an obtuse angle, it's going to be equal to the other obtuse angles. Wherever you have an acute angle, it's going to be equal to all the acute angles. And an obtuse plus an acute is always going to be supplementary. Everybody good?
Did everybody write on their paper what the O stands for and what the A stands for?
Can we write it?
No, you're fine. I just know that. Oh, I think she talked about oranges today. The A has to be apples.
Go.
Okay, so if Mrs. Summer, before you move on, so if we look at corresponding
Oh, thank you.
angles, okay, corresponding angles are what then?
Obtuse and acute.
Okay, what do you know about the measures of
Oh,
corresponding
they
angles?
equal 180.
Wait a second. Tell me a pair of corresponding angles on your picture.
No.
1 and 5.
Okay, 1 and 5. And they're both what?
Oh.
So what do we know? If they're both obtuse, what do we know about their angle measures?
They equal.
Somebody said it.
They're greater than 90 and they're equal to each other. Thank you. What do you know about alternate interior angles? Name me a pair of alternate interior angles. 3 and 6. Also 4 and 5. Well, what do you know about the measure of 4 and 5? They're going to be equal to each other. So alternate interior angles are congruent, right? Or their measures are equal. What about same side interior? Same side interior. Name me a pair of same side interior.
3 and 5.
3 and 5. What do you know about their measures? And what do we call that? Supplementary. Thank you. And what about alternate exteriors? Alternate exterior angles are, look, okay, name me a pair of alternate exteriors. 1 and 8. And what letters do you have?
Obtuse.
So they're equal to each other. Does that make sense?
Yeah.
If they're both O's, that means they're equal to each other. If they're both A's, then we know they're equal to each other. If one of them's an A and one of them's an O, then we know they're supplementary. So let's write this down. Okay. I'm going to ask you one last time. Corresponding angles are what? No, I want you to tell me about their angle measures.
They equal 180.
They're going to be what?
They're the same.
How do we say that in geometry?
They're congruent.
They're congruent. Their measures are equal. The angles are congruent. Alternate interior. What about their measures? They are congruent. How about same side interior? Why don't we have a symbol for supplementary? Sorry. Supplementary. Woo! And alternate exterior. Are they supplementary?
They're the same.
Congruent. So what the A's and the O's do, if we put the O's and the A's in the angles, when we have numbers there, we can fill them in based on knowing that they're either going to be congruent or supplementary. You ready?
Most of the relationships are congruent. The SS, same side, is the supplementary one. So think SS goes together. Same side, supplementary. That's kind of the oddball.
Yeah, same side, supplementary.
I just came up with that.
That was perfect. Okay, now we're going to use what we just talked about. May I move this over, you think? Yes. Do you all have this next?
No. We had this next. We had this next.
Okay, should I?
Go back.
Oh, this is perfect. Because we're going to use what we just talked about. Now, they gave us one measure. You see that? 75. If an angle has a degree measure of 75, okay, is that acute or obtuse if it's 75 degrees?
It's acute.
It's acute. Thank you, darling. So if this is acute, what's this one?
Obtuse.
And this one?
Acute.
And this one?
Obtuse.
And this one? Obtuse. And this one?
Acute.
And this one?
Obtuse.
Uh-huh.
acute.
Okay. Now I'm going to show you how we use this strategy. Since I have my A's and my O's already written, what I want to see you do on your test, and it'll make me very, very, very happy. We know that we have an acute measure, yes? And what is that measure that they gave us?
75.
So we know that our A is equal to 75. Is there some way that I can now find out what all my O's are going to be equal to?
Yes.
What do I do?
You can subtract it by, 180 by 75.
Thank you. So I say 180 minus that 75 that they gave me, and it's 105. And that's my obtuse angle. Does everybody see why? Because what do we know? A plus O has to equal Suki, 180. Now, right now, I could show off as a geometry student and fill in all the A's and O's, couldn't I?
Mhm.
But they don't want me to. They just want me to tell them the measure of angle 1. So the measure of angle 1 is what?
Acute.
I didn't say what type is it.
Oh, 75.
75. And how did you know it was 75?
Because they already gave you the 75 for the acute on the bottom.
Because we know that the A's are all 75 and angle number 1 has an A on it. Does that make sense? How about the measure of angle 2?
105.
Because it has a
Oh,
an O. Awesome. Does that make sense to you? Okay, let's look at the next one. Shall I wait a second? If I want? Yes. If you see this measure of 120, Janet, can you tell me what type of angle that is? It's an obtuse angle. So I'm going to put an O here. I try to leave the number so I can see it. So I'm going to put, what next to it?
A. Oh,
Okay, what goes here? Does it? Look at its corresponding angle. Thank you. Corresponding angles are congruent. So what's the 1? All right. So my A's are equal to what, people?
60.
Well, let's figure it out. Huh? What is my A? Oh, my A gonna be?
60.
Why 60?
Because 180 subtracted by 126.
Thank you. 180. Subtracting what they gave us, which is 120, leaves me with 60. So I know that my acute angle, all of my acute angles are 60. They told me my obtuse is 120. And what do we know about A plus O? It has to equal 180. Now this is only when the lines are parallel. That's really important. These angle relationships only exist with parallel lines. Now can I go through and answer the measure of angle 1? Where's angle 1? Oh, here it is. What type of angle is it?
Obtuse.
And we said that our obtuse angles have what measure? 120. Make sense?
Yes.
How about the measure of angle 2? It's an acute, and we know that our acute angles are all 60. Could you fill in this entire diagram? Yes, because now you know the A's and O relationship. Anybody have questions about this that doesn't understand what we're doing?
I have,
Yes.
how do we know when like n1 equals 120? Like 120 is the sub, right?
120 is what we determined to be our obtuse angle. We looked here, and we know that 120 is an obtuse angle. Anything above what number? 90, right? So that's an obtuse angle. And then we put our pattern on, we put our A's and O's on, and we found that this one's 120, so all of the O's are going to be 120. And since angle 1 has an O on it, we know that our O's That's our key over there. Our O's have to be 120. We'll do several of these, but the better you get with the pattern, the more comfortable you'll be solving these types of problems. So now we should be, is this what you have next?
Yeah.
Okay, good. Now you try. Now look at what they're asking you to identify, and then I'm going to be quiet for a minute. They want you to identify 4 pairs of congruent angles. We don't want you to do vertical angles. We want to see other ones that are congruent. So what technique or strategy are you going to use? If you put the A's and the O's in, will that help you to determine which ones are equal to each other? Which ones are congruent? Okay, I'll give you a couple minutes. You need to do 1, 2, and 3, and we'll talk about 4 together.